Hey Math 3, so today we are going to review laws of exponents, and this is when our bases are the same. So really quick, let's talk about an exponent. Hold on, sorry, I am using Cami, trying to be cool like you guys. So we have our exponent, which goes on top of our base. So the base is down here. For instance, we might have like 2 to the third, and remember this exponent is telling me how many times it's there. So that's actually saying the base of 2 3 times. That's the number of times it's there. So quick review for us. And I'm not sure why it's not letting me get to purple, but when we see addition and subtraction or addition or subtraction, this actually isn't a law of exponents because we don't do anything with the exponents. We leave the exponents alone. So make sure you leave the exponents alone when you see adding and subtracting. So if I looked at the expanded form, what I mean by that is this right here says 3x cubed, so 3 with 3 x's, minus 2x squared, so 2 with 2 x's, plus 5x cubed. So now we would do what we know is combine like terms. So I'm going to combine this one and this one because they have the same amount of x's. So they're the exact same base raised to the exact same exponent. 3 plus 5 would give me 8, so that would be 8x cubed. Notice I did not add those, minus 2x squared. Oops, sorry about that, 2x squared. So that one is done. Again, we're just combining like terms, so we're not changing our exponents at all. Leave those exponents alone. The next rule is multiplication. So if we see multiplication, and sometimes they'll use the little dot that's there, I could have this same problem written like this, where there's parentheses and no exponents, no multiplication or dots. So when you multiply, you are going to add your exponents. Multiplication here means you're going to add your exponents. So let's check out why. If I do expanded, whoops, sorry about that. Now you see my answer key. If I do expanded, we have 6 with 4 x's because it says 6x to the fourth times x1. If there's no exponent there, there's really a hidden 1. So 1x, and then we have 2 with 3 x's. So I'm going to multiply my leading coefficients. 6 times 2 is 12. And then I'm going to go ahead and just add the amount of x's I have here. So 4 plus 1 is 5, 6, 7, 8. So that would be 12x to the 8th. Division, since multiply is add and multiply and division are inverse operations, add would mean that we are going to subtract, since that's the inverse of adding. And this is the biggest one I suggest if you get stuck to use the expanded form because it just makes it so much easier. So if I were to expand 10y to the 6th, 1, 2, 3, 4, 5, 6, and then 2 z's divided by 5, 4 y's, 1, 2, 3, 4, since there's a y to the fourth, and then 1 z, because again, if there's no exponent, there's a hidden 1. And now I just want to go ahead and divide. 10 divided by 5 is 2. Anything over itself always reduces to be 1. Like 5 divided by 5 is 1. 215 divided by 215 is 1. Anything over itself is 1. So 4 of these y's get eliminated to be 1. And then I'd be left with y squared. A z divided by z is 1. So I'd be left with z. You can expand it and get to your answer, or I could have looked at the same thing. 10 divided by 5 is 2. These are numbers. We do numbers the same as we have since middle school. And then 6 minus 4 would be y squared. 2 minus 1 would be z, or just 1. Either way is fine. All right, power to a power is kind of like when you have an exponent to an exponent. So exponents are also called powers, and sometimes we also call them degrees. All of these terms, exponent, power, degrees, means the little number that's on top of the base. So if I have a power to a power, I highly recommend you make sure you put a 1 next to any base that does not have an exponent there, and then we are going to multiply my exponents. So I'm going to show you what this looks like in expanded form over here because I don't think I'll fit it there. So what this is saying is 2 with 2 x's, 1 y, and 3 z's. That's what this is. And then this tells me that it's there 3 times. So I have 2 x's, 1 y, 3 z's. That's twice. And then another 2 x's, 1 y, 3 z's. It's there 3 times. So if I got my answer from the expanded, I would look at 2 times 2 times 2 is 8. 2 times 2 is 4, times another 2 is 8. 1, 2, 3, 4, 5, 6 x's. 1, 2, 3 y's. And then 3, 4, 5, 6, 7, 8, 9 z's. Okay, so that's the expanded over there. What the rule is saying, if you don't want to have to expand it and count it all out, you can use the rule which says multiply the exponents. So 3 times 1 would make that 2 cubed. 3 times 2 makes that x6. 3 times 1 on that z makes it y3. 3 times 3 makes it z9. And then you just have to remember 2 cubed, 2 times 2 times 2 is 8. So either way is fine. When you have a negative exponent, so there is no expanded way for this. A negative is just telling you that they're really flipping the base, and then you're going to make it positive. So anything in the top with a negative gets flipped to the bottom with a positive. This is in the top, but it has a positive, so it's going to stay the same. And then this is in the bottom, so it's going to flip to the top and become positive. So let me just write this a little bit neater. So I have b to the 4th, c to the 5th, and normally they do put them in alphabetical order over a squared. So the a squared moved to the bottom because it has a negative. The b to the 4th had a positive, so it just stayed, and then the c to the negative 5 flipped to the top because it was a negative. My favorite rule of all is the exponent of 0. If you have an exponent of 0, it always equals 1. So, expanded form of this, it's literally saying this is there 0 times. But remember, there's that coefficient of a 1. So expanded, it would just be saying 1 times that 0 times. So my answer is 1. If you want the neater version of this, it is down here. Let me just go ahead and erase this. There you go. So you can pause it and see it a little bit neater. Remember to tell me that you watched this and that you took notes, and then we're going to try some IXL with this assignment. Have a great day, guys.